This is my final video log for Centipede, for my Centipede development game. I will start out with an overview of what was in my final version of the game, particularly going over what features got dropped and what the final product looks like. Then I'll cover implementation details and talk about what design patterns went into the final version of the game. So what you're seeing now is how the game starts up when you first load it. This is the attractor mode. If I press the arrow keys, the blaster does not move at all, and if I hit the space bar, the blaster does not move, does not change the way that it fires. So that means I was able to implement the blaster controls for at least for the attractor mode correctly. You'll notice that there is no high score anywhere up here for the blaster. There's also not the text down at the bottom saying copyright Atari. I do have text in the game. You'll see that in the single player mode. However, the high score text for the attractor mode isn't in there. All we have is just a simulation of what the game looks like with a very static attractor controller. It shoots, it doesn't move around. Now if I go ahead and hit 1, you can hear the sounds going, and I do have all the sounds in as far as I can tell. I'm going to actually go and turn off the sounds now because they are really annoying, but they are on the game, and if you would like to confirm that for yourself, you can keep playing it on your own, but I'm sure you don't care. So yeah, single player mode is pretty much working the way that you would expect it. You can move around, you can shoot the centipede a bunch, it'll die. If you die, your health goes down. You can see that you've got a score display up there. All the scores are in the game as they were listed on the Centipede website. Killing all the centipedes on the screen takes you to the next level, or at least restarts the level with whatever settings are there. Those settings don't work correctly, as I will get into, but otherwise it effectively goes to the next level. And it's hard to play one-handed. Oh, I died. Okay, well, whatever. And if you die a third time, then it goes back to if you lose all your lives, it goes back to the attractor mode. One thing you'll notice is missing is the high score. There is no high score tracking in the game whatsoever. The only score tracking is within the single player mode. It'll track the score within the mode, but as soon as you go to attractor mode, that information is lost. The other thing here from attractor mode is there's no two player mode. It's only single player mode and attractor mode. I ultimately chose not to try implementing the 2-player mode just due to time constraints. It came down to the choice between working on implementing the 2-player mode for Centipede or working more on my game mod game, and I chose my game mod game, which I hope you'll find to be an understandable choice. Going back to single player mode, the biggest thing that's missing here is the wave parser in the background and the wave manager don't quite line up correctly. I have a wave parser set up. You can it'll read in information from a data file that has a bunch of information about what should be going on in each of the waves. However, it doesn't read in all the data. It only reads in and uses a little bit of the data. And then the wave manager that controls when things are getting spawned, it uses the wave parser and tells the wave parser to get the information for the current wave. However, it uses almost none of the information that the wave parser pulls in. So when you kill all the centipedes, the wave manager in the background is incrementing the counter for what wave you're currently on and telling the wave parser to get the information for what wave you're currently on. It doesn't actually increment any values. It just is effectively using all the same values from the first wave. And in terms of just getting the game to be in a state that's reasonably playable, that is I think the biggest single thing that is missing because if I had gotten those features in, then not only would the game have been I have all the critters in and all the functionality for the blaster and the centipede. So with that in, a designer could put in all the data needed to go through a reasonably good wave progression, and you would still have what would feel like a complete version of Centipede, just missing all the niceties of high score tracking and leaderboards and two-player mode. If I take a quick look at what I was missing, let's see, I mentioned two-player mode. Of course, the sprite swapping didn't make it in, but that was never slated to be in from the beginning. I said high score tracking wasn't in. The high score and attractor mode and the wave parsing. And when you list it out, it doesn't look like very much is missing, but each of these elements is pretty large. Other than the sprite swapping, each of these is a pretty big part of what Centipede is as a whole. So, and especially as I said, the wave parsing and using the information from the wave parser, like with these elements missing, what you have winds up being just a not quite complete version of Centipede. However, discussing why I chose not to implement all of those features, it was due to time constraints. Throughout the whole course of this project, I never really ran into any technical constraints. I never ran into a problem that I had too much difficulty solving or felt like I didn't have a good solution for. And as you'll see as I discuss things, some of the solutions that should have been more, or some of the problems that should have been more difficult and challenging, I was able to come up with some reasonably clever solutions to that wound up reducing the complexity of my code or simplifying the problem to a reasonable degree. So when time constraints came around and I had to pick between other classes and this class, I decided, not feeling like I had kind of gotten what I needed out of Centipede, I decided to go with the other classes, and that's where all of the shortcomings in my game came from, just a lack of time and dedication. So let's go and take a look at what the structure is of my final project and how I wound up using the various different classes that I made. The first thing I'd like to point out is that I have a root grid object class, and if we open this up, it would be under utility gridObject.h and gridObject.cpp. The gridObject class serves almost entirely to effectively, the first thing it does is it wraps up the conversion between grid space and world space. Internally, all of my centipedes and mushrooms and all my critters and everybody, they track their coordinates in grid space. So if their position is 0, 0, they actually appear in the top left corner of the screen. Anybody who would be at 1, 0 would be right next to the guy at 0, 0. And they wouldn't be, it's not 1, 0 pixels, it's 1, 0 grid space. And then I only have one draw method for my entire game, and that's, or except for the flyweight text, but that was copied over from the boilerplate code that you gave us. The only draw call that I have is for grid object, and that's just drawing whatever the current sprite is for that grid object. So I was able to wrap up a lot of common functionality for just everything that had to go into the game into this root grid object class, and put it all together, and but basically build myself an extra layer on top of what Teal offered that simplified what I would have to write for everything else in the game. This grid object class kind of wraps together things that would be that other people might have put together as like a mushroom object, or like a mushroom field object, and a critter object, and like a player object. All these different things get wrapped together and just this one grid object class that handles all of that root functionality. One of the other reasons why I was able to do just one grid object class and not have to have like a grid object class and a critter class is because the way that I represent the grid, the mushroom field within Centipede, is not through any like strict grid ordering. For example, like a 2D array where you can actually only ever have one object in one space. In my implementation of Centipede, the grid is just a contractual thing. It's just if your position values are whole numbers rather than decimal numbers. So if your position is 1 comma 2 rather than 1.5 comma 2.2, then you're in the grid. And so for my mushrooms, they're not actually kept in a 2D array. Their positions when they're created are just set to be whole numbers, and then that has the effect of putting them on a grid without actually constraining them to a grid and having to track them within an extra data structure. And this was a design decision. I don't think it ultimately made a big difference in terms of the work that I had to do or what I had to do for tracking the mushrooms. I'll talk about the details of the mushroom field a little bit later, but it did have the nice advantage of being able to bring everything together into a single grid object class, which saved me a little bit of code duplication. Looking at my wave manager, I've got in the wave managers folder here, I've got a root wave manager object that handles pretty much all of the behavior for spawning critters and doing the behavior for managing a wave in Centipede. The only thing that really would differentiate between the different game modes in Centipede are what you do when the blaster needs to be respawned. So in attractor mode, you just respawn the blaster and you don't bother tracking anything like lives or like changing scores or cleaning. You just clean up the mushroom field like normal and respawn the blaster. In single player mode, you respawn the blaster, you decrement the lives, and if the lives are out, you go back to the attractor mode. And in 2-player mode, you decrement the current player's live, or you switch players and then decrement the new player's lives and put the new player on the screen. So everything that's common between all the different game modes goes into this base wave manager class. And then on top of built off the wave manager class, I've got attractor manager and single player manager, which just all they do is, if we look at attractor manager.cpp and single player manager.cpp, attractor manager just overrides the behaviors for respawning the blaster, and same goes for single player manager.cpp. See, single player manager actually keeps track of lives, whereas attractor manager does not. And had I done a 2-player game mode, it would have been done through that method. I would have had to do a little bit extra work to keep track of which player is current, but I do not think it would have actually wound up being a terribly difficult task. I was able to, when writing my factory and resource locator classes, if we look back under utility again, my factory class, not resource locator, my service locator class. These are 2 examples of templating that I did. You've already seen the factory class, and I've gone over the details of its implementation, so I won't be discussing that any further in this video, just because there is a lot to it, and it's not worth going over again. The service locator class is really straightforward. You just give it a type, and then it provides me with the boilerplate for swapping out a current instance of whatever this class type is. This is used for my score manager and my sound manager. So instead of having to have some like global score manager and sound manager, and then or a score manager and having to like swap out, this is the attractor score manager, this is the single player score manager, and having to rewrite the boilerplate for it, I was able to do it with templating, and now I've got service locator template score manager and service locator for sound manager, and that just that saves me a bit of code duplication. So one thing that kind of looking back at the course of the development of Centipede was the way that I plan to do object-to-object interactions. When I originally started out, I had this idea that I wanted to do everything through the collision system. So instead of having to do look ahead with the mushroom field to allow the centipede to see where the mushrooms were in order to turn, I would just put an invisible collider in front of the centipede and have that collide early with the mushrooms, and then that would allow me to turn early. And I do that with just a lot of places, and it started out working reasonably well. Sorry, I'm just checking the time of the recording. It started out working reasonably well, but by the time I got to the flea, and I was starting to try to optimize the way that the flea worked, it started to cause a lot of problems, not trying to detect if things were there using only collisions. Specifically with the flea, like trying to say, oh, is there trying to say at a specific time, is there a mushroom here? So if I only want to try to spawn a mushroom once when I reach the center of a cell, then being able to get just one collision at that time just wasn't doable. And I wound up kind of having to bend over backwards to make that work. If I had to go back and do it again, I would just not have gone with that route. I probably would have still done a lot of the interactions with doing collisions, but at least with the mushroom, at least with the centipede and the flea, having to look ahead for the mushroom field, I would have just done that with the mushroom field. Having said that, not using the mushroom field for that look ahead means that I wound up actually not using. I had this mushroom field class that I put in early on because I felt like I would eventually need the mushroom field, and I didn't actually wind up using it to a heavy degree. The only time that I made use of the mushroom field, the fact that the mushroom field tracked what mushrooms were alive, was when the blaster dies. I get the wave manager gets the list of live mushrooms from the mushroom field, iterates over all those mushrooms, resets them to maximum health, and then starts the next wave. And with the way that my factory is set up, the factory also tracks tracks all the live instances of the class that it's managing. So I could have actually done away with the mushroom field entirely and just used the factory. Had I done there are features in Centipede that would have demanded the existence of the mushroom field class. For example, in the 2-player mode, I would only have one factory managing which are the live instances of the 2 different players' mushroom fields. So I would need the separate mushroom field class to say, these are all the mushrooms that are for player 1, these are all the mushrooms for player 2. And also for if I were doing the screen swipe when the player dies and you're cleaning up the mushroom field, I was using the mushroom field to maintain the correct order so that I could do the swipe in the proper ordering rather than doing them at random. But neither of those features, 2-player mode and the cleanup swipe when the player dies, neither of those features went into the final version of my game, so I wound up having this mushroom field class that's just kind of sitting around not doing anything. So let's talk about. I said I wasn't going to talk about the factory too much, and I'm not going to talk about the implementation details to a heavy degree. However, I do think I should talk about using the special compiler that I wound up having to use to make the factory work. So if we open up my utility and factory.h, inside factory.h we have this lovely bit of code that is template type name dot 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 args. This is a variadic template, similar to how you can have an argument list in a function where you can just pass in an arbitrary number of arguments to the function, or you can have variadic macros where you can have a macro that'll just take an arbitrary number of arguments. This allows me to do an arbitrary number of templated arguments to a function. And this was necessary to, this is what allowed the core mechanic of this templated factory class. The most important thing about the factory class is that everything that you want to recycle with the factory has let's see if we can find it, has an initialize method. But each initialize method has a different list of arguments that it needs to use. For example, the centipede needs to take its position and the guy who's behind it. The mushroom just needs to take its position. The blaster needs like its position and maybe a reference to the bullet factory, whatever. And what I needed to do to make this templated factory work is to allow you to just pass in an arbitrary list of arguments to the factory's create method and have that list of arguments just get directly forwarded into the newly created object's initialize method. I guess I could have gotten around that by having the create method not call initialize, have it pass the uninitialized object back, and then have the whatever function calls create, then call initialize on the newly recycled object. That would have been fine, but it would have involved a lot of boilerplate. I would have had to make sure that I remember to manually call initialize every time I recycled an object, which defeats the purpose of doing the templated factory. The whole point of the templated factory is to avoid this repetitive boilerplate. So what this variadic template allows me to do is it allows me to pass in an arbitrary list of arguments and preserve their types, which isn't something that you can do with the normal argument lists in C++. With the normal argument list, you need to know in advance what the type is and then manually cast the type correctly, or you have to you get the type correctly, otherwise you wind up with a runtime exception. So the default this variadic template feature is a C++ 11 feature. The Visual Studio 2012 default compiler doesn't fully implement the C++ 11 standard, and one of the features that I found to be missing was variadic templates. However, when I looked online, I found that Microsoft had released a community technology preview for a more updated Visual Studio's Microsoft Visual C compiler. And this was available just as a free download. You can use it, and then you could you can choose within your project to use that compiler rather than the default compiler, and that had a more complete implementation of C++ 11. So all I had to do was get that in, and then this new compiler allowed me to use a couple of other nifty features of C++ 11. However, none of them are nearly as important as getting this in, because with this variadic templates, my factory class allows me to wrap up just a lot of boilerplate code in a really concise way. And so that's the entire story behind the special compiler. That's what it allowed me to do. One of the interesting, I guess, side effects of this is when you go to build using the special compiler, it will actually tell you that the November 2012 Community Technology Preview is for testing purposes only. They really don't want you using it in production code, which makes sense. I'm guessing it's not like a fully tested, fully functioning compiler. And so it's fine for these in-class purposes, but I wouldn't want to use it for doing stuff or for doing actual production code. Talking about best practices. I did try to use best practices to the extent I could. That included using assertions a lot. I found assertions useful when checking the state of my mushroom field, making sure that I wasn't adding the same mushroom twice or removing a mushroom that was already removed. I kept a very strict coding style. This is my personal coding style that I use in all of my projects. It includes things like padding my padding my parentheses, using using tabs for spaces, but then using or using tabs for indentation, but then spaces for alignment, which you'll see if you turn on white space as I have. Putting brackets on new lines, using capital capital letters for function names, but then using lowercase letters for getters and setters. So stuff like that, and I keep it very consistent. I used a formatting tool called A Style Formatter, which you can get as a plugin for Visual Studio, and and I could have it automatically format the document on save. So if you look through all my code, it's very consistent and clean, and there should be very few stylistic mistakes or inconsistencies within the code base. Now for my wave parser, my incomplete wave parser. I did choose to go with a JSON formatting for my wave files. And if we take a look at the wave file that's actually being used by the game, the way that I chose to have this set up is in your JSON file, you define each of your waves. So here we've got wave 1, wave 2, and then you could just define arbitrarily onwards, wave 3, wave 4, wave 5. And then within each of the waves, you can give definitions for each of the critters. So you can give a definition for the centipede, for the spider, for the flea, for the scorpion. And then the wave parser will parse those in, then we'll pass them into the wave manager, and the wave manager can use those as it spawns stuff. And I wanted to make it so that since a lot of this information I imagine would be repeated each wave, so the centipede is going to have the same speed for a couple of waves before that changes. I had intended to allow the developer to just leave out any information that was repeated that was supposed to stay the same from the previous wave. This, however, had the consequence of meaning that I had to ensure that every piece of information in the wave was saying information. So, for example, here in wave 1, we had defined there to be one centipede of length 5, and in the second wave, we wanted to have one centipede of length 5, and then one centipede that was just ahead. And if the designer had made a typo, if they had done initial lengths in the second wave, the wave parser would have looked at this, would have looked for something called initial lengths. It would have completely missed that there was this init-al lengths member, and it would have reused this value from the first wave. So I needed a way of, and this would be completely opaque to the developer. They would think, oh, there's supposed to be 2 different centipedes in the second wave, but there's only one centipede, just like in the first wave. And if this is, for example, something that was supposed to, if it's defined once in wave 1 and then a new value is put in wave 5, it may be just completely obtuse to the developer why the values aren't appearing the way that they expected them to be. So what I needed to do was effectively go over everything in the wave file, look at every single variable name in the wave file, and say, is this a valid thing? So is centipede supposed to be inside of wave? Is initial length supposed to be inside of centipede? And so on. Is the value of initial waves an array? Are all the values in the array numbers? And needless to say, I didn't actually do all of this checking. However, I did spend a solid day or so trying to write all of this checking functionality. I got a portion of it done. I believe I check if all of the top level objects are in the format of like wave number, and then I check if all of the waves only have centipede, spider, flea, scorpion, etc. Um, and I did lose like a day of like a solid day of development trying to do this before I stopped and realized that it was more important that the wave manager actually use this information than the wave parser give the developer solid feedback. And so that is probably like I would have had that stuff in the wave manager. The wave manager would have made better use of the information in the wave definition files had I not wasted a bunch of time on something unimportant. And that's just a kind of a lesson that I learned in the process of working on the wave manager. Now, other than that, I don't really have any regrets or qualms about the what I've chosen to do with this JSON formatting for the wave file. Um, there is the potential that I hand this to some developers and they go, "Oh, I don't want to do JSON. This is poorly formatted, or it's a pain in the ass, and it's too easy. Like, oh, I have to put braces everywhere, and then it may prove not to be a really viable method for for designers to use. Possibly. I think it would work out well. Maybe in production code, I would have gone with something else like YAML. YAML is very readable, and you can actually explicitly reference back to previous things. So instead of having to do this automatic flow through with the values, I could just have them explicitly say reuse the value from the last wave, and that would have made things a little bit clearer for everyone. But that's all there is to the wave manager. It's not complex. I didn't wind up implementing everything, so it just winds up not being very important. So taking a look at the design patterns that I wound up using, I could actually only think of off the top of my head 3 big design patterns, other than the flyweight, which there was only one use for the flyweight, so it's not really worth going over. I only could think of the singleton strategy and object pool, and I'm sure we talked about something else, but it's not coming to mind, and is probably not used majorly throughout the code base, so probably not important. Singleton. I only have a couple singletons in my game, and only one of them is really a singleton. And that's the random class. If we look at random.h, random is a random class. It's actually got a private static instance of itself, and all of the public static functions call a method on the or use some information that's in the the private static instance. And the private static instance creates itself. So this is actually the traditional gang of 4 singleton pattern. This is exactly as you would expect a singleton pattern to be. The other 2 singletons, in air quotes, are my service locator and my factory. The factory is a singleton in the sense that you only get a single instance at a time. However, I kind of turned it into an anti-singleton pattern because, it seems, okay, there we go, it's unfrozen on me. Because if you take a look, hold on, let me just collapse these functions. That's not it. What? There we go. Okay, so if we look at these functions, we have our most important methods are create and it's basically like create, live count, cache count. You'll notice that these are public, but they're not static, which means you actually need to hold on to an instance of your factory class to be able to use the factory. And I did this because I didn't want to have global access to I didn't want to have global access to the factory class. That didn't make sense. Allowing global access to something like a factory seemed like making all of your member variables and all of your functions public is just bad practice. It's bad encapsulation. And while I realize that that's an arguable point, that's what I wound up. This is the way I wound up doing it in my code base, is not allowing this global point of access. So instead, you create a factory class, and the factory will check whether or not an instance of that particular factory exists. If it does, it'll yell at you. If it doesn't, you're good to go. And now you can hold on to that one instance of the factory class and pass it around to anybody who needs to be able to use that factory. In my case, the wave manager is the one that holds on to the different factories and then will give it to whoever needs it. For example, the wave manager creates the blaster factory, and then each time it recycles the bullet factory, and then each time it recycles the blaster, it hands the bullet factory down to the blaster, and then the blaster is able to spawn new bullets. The other guy, my service locator, is technically a singleton because it has all the properties of the singleton. However, it's also, I would call it a service locator pattern because if we open up servicelocator.h, rather than having a constant instance of whatever service it's providing that's just accessed through public static methods, you actually can change what the current instance is, and then you can get the current instance and then operate on that instance. So while a singleton would give you a list of the public member functions, this one just allows you to get the instance and operate on it. And this is very close to being a singleton. There might not be much point differentiating between the two patterns. This one just was more appropriate for doing the sound manager and the score manager, because the sound manager and score manager needed to be changed between attractor mode and single player mode. And instead of having to have certain things get access to the private instance of those singletons and swap them out, this allows me to just swap out whatever the current object is, and then hand that object off to whoever needs it. And in this case, I am using a global point of access. Anybody can ask for the current instance of the sound manager or the score manager, and since so many places needed them, I didn't think it was as big a deal. And this didn't seem like a likely case where somebody would improperly use the sound manager. The score manager actually would have been a good candidate for more of that anti-singleton pattern. I wouldn't want somebody mucking around in the physics code to accidentally say, oh, when these two objects collide, that's when we're going to change the score. But it's not how I decided to do it in this implementation. The strategy pattern was used all over the code base. The Centipede is a strategy. Blaster controls are strategies. Wave manager strategies. Score manager and sound manager are strategies. There might even be a couple more in there that I'm not even thinking about. The only one that's interesting in any way is the Centipede. The Centipede doesn't have a separate object to manage the strategy. It uses pointer to member functions. And then I swap out the pointer for the current member function, and the update function always just uses the current pointer to member function. When I'm doing it for this project, it was okay. There's only two different types of movement the Centipede can do. It can either turn or go straight. And so it didn't really clutter up the Centipede too much by having all the different strategies in that one class. However, were it any more complex, I probably would have split the strategy off into a separate class, because I did wind up having to put a bunch of state information in the base Centipede class to get the strategies to work and allow them to communicate with each other, and that just put a lot of clutter in there that could have been avoided and would have been necessary to avoid had the centipede been any more complex than it wound up being. And then for the object pool, obviously the factory class, and you've seen the factory class plenty. No need to go over it any further. Um, Other than that, that's there's not much to talk about. I mean, there's a lot of nitty gritty details in the code that could be gone over. I do have separate classes for the different, or separate scenes for the different game modes, and I switch between scenes, but there's not too much to go into for that one. Beyond that, um, all the critters do work. They're not all quite as performant as I would like. The flea especially bad because I'm doing a bunch of checks every frame in the update function, and that's something that, like I said, I could have fixed using look ahead with the mushroom fields, and I just didn't get around to it because the kind of crappy implementation worked, and I had other features to focus on. Um, yeah, looking at the different code, there's just nothing much of interest in here other than what I went over. So that's it. I don't have much more to say, and oh my god, this video ran really long. I sincerely apologize for that. I'm going to stop this now.